Good games? Like good graphics? Good.
I think that before is not used too much. That's good.
Whoever had it didn't use it so much. Yeah. That's good for you.
It's cheaper than i5.
Yeah, i5 is expensive. It's good when you buy something second hand and the last person didn't use it so much.
Yeah.
So the car that we drive, we bought it second hand, but the last owner, he only drove about like 10,000 kilometers.
Oh.
I thought that was good.
Yeah.
The car, he got it and he had it for 3 years.
Oh.
And he only drove 10,000 kilometers and then he sold it. And it was a nice car, you know?
Yeah.
But if it was new, it'd be twice as expensive.
Yeah.
It'd be like 20,000, but we got it for 10,000. And we're like, oh, that's, you know, that's good. So you got a good deal on your laptop, you think?
Yeah, it's okay.
Good
It's
price.
the war,
Yeah.
It's the war.
I think that's good. That's good. Okay, so where did we stop? So you plotted this, yeah? So as you can see, the graph is exponentially decreasing. Oh yeah, so now, what I'm going to do next, you need to know for the exam. It's a proof. They could ask for the exam. Okay, so it's a proof. So, what I'll do first, just like what we did in the last lesson, so I'll put a log here and a log here. Okay, so Andek or Chow, do you know what rule I need here? This is like log AB.
So log n minus log e
Oh no, plus.
plus
Yeah, log AB is log A plus log B.
Log E.
Log AB.
plus
Log AB is log A plus log B. The first rule of logs. What's confusing you? ln AB, yeah, is ln A plus ln B.
And LNE is nothing.
Well,
No.
kind of. ln E, not nothing, but they cancel.
They cancel.
Yeah. So you get ln equals minus lambda t plus ln log 0. Now, if you make a plot where this is t and this is ln, then can you see that this guy is like y? Yeah? And what's this guy like?
the rate
No, not this guy.
oh the intercept
No, be careful. This guy? The t?
oh it's time
Yeah, so what's that like on the graph?
still x-axis.
It's the x-axis. Good. Okay, good. So, Andek, I think you might have the idea. What is this constant like?
Is this the straight line?
Yeah. What? But you said it a moment ago. What does it represent? It's
slope.
the slope. Good. And what about this one?
Is the intercept.
The c. Yeah. So, you see that graph you drew for me, the one that goes like this. You can say that lambda equals minus m. That's the result, okay? Lambda equals minus m. So, if you look here, can you look here, and is this a pencil?
Mm-hmm.
So if you were to, that's your straight line, okay? If you just go across here, so here to here, divided by here to here. So, how big is this? What's that, 4.5? And that?
1.75.
And then how big is this? 10.
10.
And because it's going down, minus. Okay? So what we can say is that lambda equals minus m. There's the m. So minus m minus m is that. Is that. Okay? So lambda, you can calculate it from this graph. If you can make this graph, you can find the lambda. Okay? They do that in the exam. Okay? In the exam, what they'll do sometimes is they give you this. Part 1 is first you have to make this. Part 2, you have to make this. Part 3, you have to calculate m. Part 4, they ask you the lambda. And then part 5, they ask you the half-life. And then you can get the half-life by using this formula, because you know this and you know this. You see? So it's a section B question, usually. Yeah? So when you write that proof down, I want you to do this one as an example. Chow has the number on his calculator. Okay? So you can add in a triangle here. Yeah? Okay, good, good. Oh. Yeah?
Why is 4.5 minus 1.74?
Oh yeah, it's the height. This over this. Here, I'll show you here.
I'm confused.
Yeah, look. What you do is you draw a triangle.
Yeah.
And this m will be this over this. The rise over the run. This length divided by this length. That's the m. You didn't know this? You don't know this? Look.
I was supposed to find the lambda of this one, the gradient.
You can find the gradient from using the triangle. What you do on your graph paper, you draw a big triangle. Now you could draw a smaller triangle, that's fine. So just draw a big enough triangle. This is called the rise. This is called the run. And the m is the rise over the run. You didn't know this? Are you sure?
Yeah.
Oh, okay.
You turn to
Back here.
Sorry. There's something on my calculator. Not that strong, but it keeps giving me answers in fractions.
Press the SD button.
Where's the SD button?
It's
Oh. Okay.
Yeah.
That's how you do it.
yeah.
I just got this new calculators.
Oh, did you?
Yeah.
When'd you get it?
On the weekend, last weekend.
Okay. There's no rule that says you can only have one calculator, so you can use both in the exam.
Yeah.
You know,
I saw someone bring 3 calculators.
who brought 3 calculators?
I'm not sure who, but I saw someone.
So one of the medicine students.
I don't think so.
I think I know who it is. Was it Mo? He has a was it a graphing calculator? Was one of the calculators a big graphing calculator?
One like this,
Yeah.
and then this and one pink one.
I don't know who that is.
Not really sure, but.
So I've done that one already, and we've done the proof already, and this is the result. And you wrote the result down, didn't you? No, you wrote this down, didn't you? So here, lambda equals minus m. Oh, okay, if you want to write this down again. Now, Andek,
Yeah.
we just proved this. This was the proof we did, okay? We proved that you can put this on the y, this t is the x, so then the minus lambda is the m. Now what's interesting is, if you use this formula, or this one for activity, is the same result, that the m is also the minus lambda.
Basically the same thing.
Exactly the same thing. So if you plot, where's your plot now? Where's your graph? Oh, here. Here this was log n. Okay? If you use log a, you will get the same answer. So you can use n, or you can use a. Where's your a? Where's your a? Did you miss this class?
Last week,
Yeah.
I missed one class.
Ah. Have you got it? Yeah, you missed. Did you miss this lesson where we had this formula? The radioactive decay equation with the A. You missed this, I think. Yeah. Yeah. You missed this.
Oh, Friday, yeah.
Were you there?
I was here, I was a bit late, about half an hour.
It's a bit late. So I think what you could also add to this is it's also true for A. If you graph log A, okay, the lambda you can also get from the graph of log A. Is that okay? Yeah? You want to write something down? I don't know. Yeah.
Something
Yeah, actually, yeah. There's only one question to do, but it's very, very similar to the example we did already. Okay? So here is time and here is activity. What should I do first? Yeah, ln of what? This or this? This one here. Okay. Then what do? You make the graph, which is part A.
Yeah.
Okay. Part B, how do you get the lambda?
Rise over run.
Right, yeah, the triangle.
Yeah.
You get the slope, so that's okay.
Yeah.
Yeah. Part C, how do you get the half-life? You use the formula.
Yeah.
What's the formula? Log 2 over lambda.
Yeah.
Yeah. Now, this is the hard part, which I want, well, not the hard part, but I want to do this one here. What is N0?
Zero is the intercept.
Not quite, because when you draw your graph, this here would be log A0. It's different, okay? Now look, it's no problem, because what you could also do is this. If you look at your table, what's A0? A0 is 10 moles. Okay, so A0 is 10 moles. And I want N0. Now, I can just use this formula. A equals minus lambda n. Okay, do we know the A? We do. Yeah? Can we know the lambda? Yeah, from where? From the graph. Yeah. And do we know the n? No, but that's what we want. So can we get this? Yeah. Okay, so this formula you missed on Friday. Okay. And lastly, what formula would give me the last answer? What is n at t11? How could I do the last part? Yeah?
ln n equals to lambda t.
So, not that one. Nice try though, not that one. Which formula? This one. This one. Okay, do you know n0? Yeah, because that was the last question. Do you know lambda? Yeah, because that was last question too. And the t is 11. So can you know the n when t is 11? You can. Okay. So there's only these two parts that are new. These three are the same as the example we did. Okay. So look, what example did I give you in the book? Just the one. No, two. Is it?
No, I mean different value.
Yeah, it's the same thing, isn't it? Yeah, can anyone see the mistake here?
What?
In the graph? I'll tell you the mistake. It's here. We don't write time bracket years. We write time / years.
Yeah.
Yeah. Anyways, yeah, this question here is the same as my example.
Yeah.
So can you just take 5 minutes doing, yeah, easy peasy. Can you just take 5 minutes doing question 1 and then you can go. What class have we got at 11?
Maths.
Doubles?
Yeah.
Okay.
Right here.
Oh, you don't have to move. Okay. So you just take 5 minutes doing this question, please.